Hi everyone, I'm Sai and I'm a maths tutor here at Quantum Education based in Melbourne, Victoria. And today I would like to tackle a VCE Math Methods problem that is very, very common in exams. The particular problem that I want to solve here today is taken from the 2023 exam 1, which is a tech-free exam. And this is question 2 of that paper. So this question asks us to solve e to the power of 2x minus 12 equals 4e to the power of x, for x being a real number. So this is an example of an exponential equation, which is a very, very common sight in VCE maths and beyond, if you're interested. So in order to approach this problem, actually, before we approach this problem, I would encourage you to pause this video and give this a try if you haven't already. And then we will go through the solution of this. So assuming that you've had a go at this, I will go ahead and present my solution to this problem. So this is an example of a very, very common question called the hidden quadratic. This is the approach that I will employ to solve this problem. And in order to see that this is a quadratic, well, you can rearrange this expression to make the right-hand side equal to 0, much like you do with quadratics, i.e. You rearrange your expression, you make one side equal to 0, and then you either factorize it or apply the quadratic formula or solve it in any other way. We're going to do something similar here. So in order to do that, I'm going to move the 4e to the power of x over to the other side and write this as e to the power of 2x minus 4e to the x minus 12 equals 0. So hey, our right-hand side is 0. This is starting to look like a quadratic, but some of you may be wondering, so how the hell does that look like a quadratic? I don't understand you. Well, hopefully the following substitution will make it clear. I will make a substitution and let a equal e to the power of x. Now, that requires a bit of thought, but we can write this entire expression above here in terms of the variable a that we've just defined. So our second term in our expression becomes 4a because a is just e to the power of x. So I'm just going to put that back in. Our 12 just stays as 12. But hey, what happens to that first term? Well, in order to see what happens to the first term, let's think back to our index laws, which say that if I have e to the power of 2x, I can write this as e to the power of x all squared, right? This is just from your index laws, which you may be familiar with. But hey, the variable a is our e to the power of x. So the first term in this expression, this e to the power of 2x, is nothing but a squared. So this is a quadratic expression now in the variable a, which we have defined as e to the power of x. And so how do we solve this equation? Well, we just need to solve this equation for a. And the way we do that is just as we normally do with regular quadratic expressions, i.e. Either factorize it or apply the null factor law, apply the quadratic formula and then use the null factor law, and so on. So at first glance, you may be wondering how to approach this. So what I would do is to find two factors of 12 that would add to give me negative 4 rather. So let's list all the factors of 12. So we got 2 and 6, 3 and 4, 12 and 1 if you really want. Of those pairs of factors, the pair that would give us a total of that would add to give us negative 4 is negative 6 and positive 2. So then we can write this out as a minus 6, a plus 2 equals 0. If you don't believe me that this factorization is equivalent to our quadratic here, I would encourage you to expand this out and verify for yourself. Expand this factorized form out and see that you get back to what we started with. Okay, now it's just a matter of applying the null factor law. Well, in that case, we have two solutions for a. We have a equals 6 or a equals 2. Negative 2 rather. Now, it may look like we're done yet, but not quite, because we've solved for a. But in fact, our question asked us to solve for x. So now we have to substitute back in the definition of a, which was e to the power of x. So we have e to the power of x equals 6 or e to the power of x equals negative 2. Now, some of you may be wondering, hey, there are two solutions, so I can just, rearrange both of these expressions and find two solutions for x. And the answer to that is you've got to think a little bit closely about this. The first expression, e to the power of x, is fine. E to the power of x equals 6 is fine because 6 is a positive number. If we visualize the graph of e to the power of x, if we think back to our shape of our graph e to the power of x, it looks something like this. We have a horizontal asymptote at y equals 0, y equals 0. And our curve looks something like this. What you'll see here is that e to the power of x can never be equal to or less than or equal to 0. So it cannot take on any negative values, which means that this solution is not a valid one. So in fact, our quadratic only has one acceptable solution. Now we have to justify that this is because e to the power of x is greater than 0. So the e to the power of x equals -2 is invalid because we want our exponential to be positive. So in that case, we have e to the power of x equals 6 being our acceptable solution. So to summarize, we have e to the power of x equals 6, which we must solve for x. Now, this is where we need to recall our understanding of logarithms. So in order to undo an exponential, when you have a variable in your exponent, the way you sort of undo that, just like you would divide in order to undo a multiplication, is to take the log base e of both sides. So in that case, x just becomes log base e of 6. And this is the answer that we are looking for. Remember, you do not have a calculator in this question, so you are expected to leave your answer in exact form, which is exactly what this is here. Okay. Another common notation that you might see is ln of x, so ln of 6. The ln here stands for the natural logarithm. It's the same thing. I have written it out like this, as log base e, just to make it a little clearer. So the solution is x equals log base e of 6, or the natural logarithm of 6. That concludes our solution to this problem. If you had a different approach, please let us know in the comments or by email. But I hope you found this video helpful, and I look forward to seeing you in the following months. Toodles.